Hey, geometry, we are going to start our journey officially with proofs today, and starting with algebraic ones, because that is what you are familiar with. And so in algebra, when we work with solving equations, we always talk about opposite operations, right? And that is the process for solving any equation. But why it works is what we're going to focus on today. So we do have some notes to take down, and then we're going to practice some equations down below there. But the addition property, okay, notice all key points. They are all properties, which means that they are eligible to be used in these formal proofs, okay? So the addition property says if A equals B, notice this is a conditional statement here, right? If A equals B, then A plus C equals B plus C, right? If A is the same as B, then A plus C is equal to or the same as B plus C. Someone justify that, why it makes sense. Damien. You do. It was assigned 2 weeks ago, though, so you've had plenty of time. Yeah, but I was gone. Not my fault. So someone justify why this makes sense. Kylie? Yeah, and as we know with the equations, if you add the same thing to both sides, it remains balanced, right? That's why we have the opposite operations method. We're adding something, subtracting something from the same side. It's going to keep that equation value the same, okay? This is pretty much the gist of what all of these look like for the most part. So if you're confused as to why this works, you're going to be confused as to why the rest of them work. So if you have questions, now is the time to ask. No? Ellen? Oh, no. Very well. Subtraction property, you can probably guess. If A equals B, then A minus C equals B minus C. You can subtract the same thing from both sides of an equation, and the value is not going to change. Okay, you're taking the same thing away. The multiplication property, if A equals B, then A times C equals B times C. If you have two things that are equivalent and you multiply them by the same value, they're still going to be the same thing. Yes, Damien? What is it?
Okay, so if A equals B, then A divided by C equals B divided by C.
If A equals B, then A divided by C is equal to B divided by C, with one exception. If C is unequal to 0, because if you divide by 0, you get the undefined, which has no value. And if something doesn't have a value, it cannot be set equal. Okay, 0 is still a value, right? But dividing by 0, that undefined, that is not a value. So as long as C isn't 0, then the division property is true. Okay? The substitution property says that if A is equal to B, this one's a little bit more lengthy. I should put 2 lines for this one. Then A can be substituted. I should not use the word substituted. Can be replaced. We'll put that. Can be replaced with B in an expression or equation. Yeah, mental note for next year. 2 lines for that one. If A equals B, then A can be replaced with B and vice versa in an expression or equation. Okay? Yeah.
How come you didn't notice that you should have 2 lines last year?
I probably did, and probably said the exact same thing and then promptly forgot. That's usually how my brain works. Yes.
Can you fix it now? No.
I could fix it now, but that would actually throw off the form. No. If I remember, I'll fix it when you're working on your own proofs. But are we already groaning about doing proofs? You haven't even done them yet. They're not that bad. Well, I'll show you after we talk about the distributive property. The distributive property. Same distributive property as you've used before. This one doesn't start with A equals B though. This one is no if. If you have, we'll keep with C. Hold on, I'll make up my mind. Okay. C times the sum of A and B is equal to AC plus BC, right? You can distribute that C term, that coefficient, into the parentheses, and you multiply. Okay, same distributive property that you've been using before to solve equations, simplify expressions. Any questions on those 6 properties? 3, 2, 1, you are quiet. No. Okay. So when you write a formula, I'm excited for you here. This is going to be fun stuff here. When you write, okay, writing proofs involves having, Catherine, a statement and a reason. You are stating something and then defending why you're able to say that. Okay, which is what deductive reasoning is, right? You have a conclusion and you back it up with evidence, with facts, or whatever. Okay, so when you start to write these, you're going to have a statement column, then a line separating the two, and a reason column. Okay? Statement and reason. What you are able to conclude and why you're able to say it. And what? Yeah.
This is like a crime scene, and we have to.
Kind of, yeah.
Yeah.
Sure. Yes, let's go with that. Okay. And the first reason of any proof should be what you're given. What is the information you are told, you are provided? Which in this case is the equation that we're starting with, right? Our first statement is 4 plus 8x equals 10x minus 10. Why? Because that's what we're given. Okay? Every proof should start with a given statement. Now, click on your algebra brain. What would your first step be, or what could your first step be to solve this, Aiden?
Move all the x's over to the left side.
Okay, so Aiden wants to move all the x's over to the left side. Could you move them to the right side? Yes. Could you start with your constants? Yes. But we want to move them over to the left, and so let's do that. Hey, if you do it differently than I do, and you have a question on why my proof looks different than yours, I recommend doing it the same way, just so you can see the setup. If you want to do it your own way in your homework, fine. But I would recommend doing it the same way here so that we can all see it together. And so what we get after we move our 10x's over is 4 minus 2x equals negative 10. We don't have to show the work here like we did in algebra because we're going to now defend it. How did we get from here to there? Claire, do you have another question?
I have a question.
Go ahead.
Why wouldn't you want to move the 8x over? Because then you're not working with the negative.
It's all up to whoever's solving it. He mentioned this, so we're going to do it this way. If you wanted to move the 8x over so you didn't have the negative, that's totally fine, right? One way is not better than the other here. Okay, we're focusing now more on the reasoning and the structure. Alex? I don't know. Yes, it does, but that's not the goal here. The goal here is to get the proof. Okay, Damien? Hold on, we haven't finished this yet, right? Justify how we got from step 1 to step 2. What did we do? Okay, we move that 10x over. I'm going to show it in red because you don't have to write this in here when doing a proof, but this is what we did do. Which of those properties up above shows that? Joey? The given is what you're given. It's literally what you start with. Okay? Yep. Nope, given. Okay? Given. The only other option for that is when you've got a diagram that's marked, you can say it's marked, but your two options are given or marked. Those are your ways to go. Kylie. Subtraction property. And so you do need to write subtraction property, not subtraction, subtraction property. If you did want to abbreviate, you could put the sub-prop, S-U-B-P-R-O-P, sub-prop, but you need to have subtraction property. Okay? You need to be careful with abbreviations because if you're a lawyer in the courtroom and the judge asks you a question and you respond with IDK, that's not a good look. Okay? Oh, brother. Well, no lawyers in here, at least not you or you. Joey. No, because for substitution, you wouldn't put subprop. You'd write out substitution.
Can we put subs? Can we do that?
Sure. I'll let that one go. Okay. Next, what will we do next? What do we do next, Kylie? What would we add 4?
Addition property.
Adding 4 to both sides would give us 8 over here.
Or no,
Subtract 4. And that would leave us with negative 2x. Joey, warning for you. Quiet, please. That leaves us with negative 2x equals negative 14 here. And what did we do to get there? Subtraction property or subprop. Okay. Proofs, everybody. Proofs. Here we go. Schlafer, thank you for that. What would we do next, folks? What would we do next? Solve this equation. Alex. I'm sure there are some legal terms that can be abbreviated slightly, but the way that you folks like to abbreviate would not hold up in court. Right, exactly. Yeah, whatevs. Yeah, that wouldn't fly either. That wouldn't fly either. 3, 2, 1, you are quiet. PIP. Shh. Joey, what do we do next here? Go ahead.
Okay, so we divide by negative 2.
Yes, and that would give us x equals 7. Defend that step. No, division prop. Okay. In red here, you don't have to write this because with proofs, you don't have to show your work. But what we did was we divided both sides by negative 2, right, to get that x equals 7, and that is the division property. Okay. The same people that are constantly talking right now are the same people whose tears I'll be mopping up from their papers when we get to actual geometric proofs, and you have no idea what's going on. These are algebraic proofs. We're starting here because you've done this before. Flip your binder ahead a couple of pages and see what's coming up. Okay? So, 3, 2, 1, you are quiet. Max, warning for you, I just counted down. Catherine, warning for you as well. Okay, so I understand that this is probably, for as much as we've talked about proofs, this is kind of like, oh, this is, okay, pay attention to what's going on here because you will get docked points if you don't have the right format. You will get docked points if you don't have the proper way to logically reason through something. Okay, And so just keep that in mind. I've got the tissues ready when we get to PO16. Kylie.
Can I go back to algebra?
You may not. We're past that point. The ship is not turning around. Alex. Folks, Alex is asking a valid question. He's asking if you can do 2 steps at once. Warning for you, Damien. You are able to do multiple steps at once if they have the same reason. Ellen, warning for you as well. If they have the same reason. So if the reason is the same, you are able to do both steps at once. Could we have jumped from here all the way down to step 3 in one shot? That's a little bit too much because there were same reason but 2 different actions. I'm saying no for right now just because this is you didn't ask. No right now because this is so new, but just like in algebra, once we got something, we're able to cut corners. Eventually, yes, but not quite yet. Okay, next one. How do we start? Alex, how do we start this one? What? Nope. How do we start?
Do we have to make a T-chart for every single question?
Yes. How do we start?
We make our T-chart.
Okay. We have our statements. We have our reasons. How do we start? Bryn.
Like
Given.
then, yeah.
Start with what is given. Always start with what is given. That is your first step. Okay? And what is given to you is the equation 7 minus 12 times n minus 4 equals negative 18n plus 37. Okay? Now walk us through the process to solve this equation. What would we do first? Kylie. Distribute. And so step 2 would be 7 minus 12n plus 48 equals negative 18n plus 37. And that is the distributive property. Okay? Again, you have your conclusion, you give your reason. You have your conclusion, you give the reason. What would we do next? What can we conclude based off of this? Liesel. Okay. Distributive property. The numbers is just what we get after we distribute. Distribute the negative 12 in, and that's what we get after we distribute in the negative 12. Jack, Catherine, second warning for you. I'm answering your question. Distribute the negative 12, and what we get from doing that is what the second line is. Okay? Damien. Yes.
How many warnings do we get?
3. You're on 2.
Okay, and what is those thingies saying on the right side of number 2?
Distributive property.
No. Other 2.
It's what we get after we distribute the negative 12.
I can get 18.
You don't have to. Just distribute the negative 12. You've been through algebra. Now, Liesel's saying we need to combine like terms. And we're going to combine this 7 and the positive 48 to get 55. Okay? And even though combining like terms isn't a property that we have listed above, it's what we did. Okay? And so sometimes your reasoning can just be what you did to get there, right? What did we do? We combined like terms. There is no combining like terms property. There is no special definition for it. It's just what did you do? Damien, sit flat, please. You combined like terms. So we have properties, we've got definitions, we have theorems, postulates, or just what did I do? Okay? But you have to have a reason for it. Alex. Okay. Next step, step 4. What do you want to do now? Ellen.
Subtract 37.
Okay, so we subtract 37 from both sides. We get negative 12n plus 18 equals negative 18n. Alex, warning for you, it's your second. Okay, and what we did was we did the subtraction property. and we subtracted 37 from both sides. Now what? Now what? Damien.
Alright, so we moved it to 5. We're on 5 now.
Yep, we're on step 5.
Yep. And then we add 12 and for the other side. So we add.
And what property or definition or theory of the addition property? Exactly. What did we do? We added the same thing to both sides of the equation. Okay? And then, last but not least, Lexi. And how'd you get there? Okay, because of the division property. Divide both sides by -6. We get -3 as our value for n. Okay. Now, Lexi, I'm going to pick on you a little bit here. Okay. The way that she worded that, she put n equals -3. Because we moved our n's all to the right side, when we do that final step of dividing by -6, we have to keep our n's on the right side. There's another property that we haven't learned about yet that allows us to move the n and to switch that. But just for the record, you can't flip-flop the side that ends on without stating that you're doing it and giving a reason why. Okay, so we're not going to do it today because we haven't talked about it yet. But just for the record, whatever side your variables are on, you've got to keep them there. All right, unless you give a reason for moving it over. Okay, just so you know. Yeah. Yes, you do. Then you would not get points. Okay. Proofs are a very specific thing, right? Very specific thing. You must defend what you are doing. Yes, Damien. I feel like we've talked about this a lot. Using deductive reasoning in your logical problem solving, okay? Those of you that have generally more success on the math packets are because you're using deductive reasoning and you're able to logically think through something. You're able to justify your answer. For that miles per hour question with the car and the wheel turning, those that came up with 425,000 miles per hour for a car, no, right? No. I've had people turn in negative answers for that one. Okay, you can go very slowly in a car, but you cannot go a negative speed. You're still going a speed backwards.
So you're going to negative speed.
Anthony, I am going to use deductive reasoning and logic here. Have you seen on the speedometer, 0 is the lowest value? When you go in reverse, it continues to go up for a speed, it does not go down to negative speed.
No,
Okay.
it goes down.
See, now that's an example of just, folks, Anthony's doing here exactly what I'm trying to teach you not to do here. He's saying something that he knows is false.
No,
He's trying to overpower me.
it's an old truck. It goes backwards.
And now he's trying to make a joke because he knows he's wrong, but doesn't want to admit it. Okay? There is no speedometer, Anthony, that goes negative. Just like there's no negative distance, there's no negative speed. Okay? Negative distance are not negative numbers, Anthony.
I said they were in a different universe.
Right. And now we go to the science fiction, because when people know that they're wrong, they start to just either be louder or make up stuff or make jokes. Damien, sit flat, please. This is exactly the type of arguments and arguing that I want you to avoid doing, because ultimately it doesn't accomplish anything. Okay? It doesn't accomplish anything. You have to have a reason to back up what you are saying. Okay? And just because you shout something louder or make people laugh doesn't mean it doesn't make you right. Now, I'm picking on you, Anthony, because you kind of,
I fell into it.
you did.
It's like a
Yes. Okay? But Damien, that's the reason why. Okay? Alex. Still not a negative speed.
I mean, doesn't go anywhere. It's neutral.
Well, the speedometer, but it's still not a negative speed. There's no such thing as a negative speed. It can't be wrong. There's no place for it to go. It stops at 0. It can't go any lower.
Ours is broken.
3, 2, 1. You are quiet. Yes, Joey. When we have time at the end of a class period that people aren't arguing and carrying on, I don't have to give out 15 warnings in a class period. Ellen, you get 1 extra recess total. Mhm. Individual prizes are for anybody. Class prizes are just the first person to reach it, then the class gets the prize, then that's it. Otherwise, like the younger grades, they'd be taking extra recesses once a week, and the teachers would get mad at me. So it's a one-time thing. Homework for tomorrow's a retake day, and so for Monday. On page 109. Six through 14. You've got correct. You've got tonight, Friday, Saturday, Sunday, 4 days to 9 questions. So it's like 2 a day. Monday. 9. That's high math.